Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone.
Hello, everyone.
Okay. I am still hearing an echo, so to our reactor host, if you can fix the echo, that would be great. All right, I think we're good now. Okay. All right, thank you, everyone. It's very distracting to talk and hear yourself, so just wanted to fix it up. Okay, welcome to our series, Hosting Agents on Microsoft Foundry. This is a very timely topic, as there was just a huge new release last week of a new platform for hosted agents on Foundry that is way faster and speedier and really designed for agents. So this is a great time to be talking about this. So we are doing a 3-part series. Day 1 today, we're going to be using Microsoft Agent Framework to deploy both agents and workflows to Microsoft Foundry. Day 2 tomorrow, actually Wednesday for this series, we'll be doing LangChain and LangGraph and deploying those to Microsoft Foundry because that's a very popular community framework that many folks are using. And then on our final day, on Thursday, we'll be doing quality and safety evaluations with Foundry on those agents. So hopefully we can give you a good foundation for hosting your agents and workflows on Foundry. Now, we also have this series available in Spanish if you do speak Espanol. If you have not registered for the series yet, please do so. We'll share the link in the chat. And that way you'll get notified when each of the streams comes and, for all of the resources and YouTube recordings. Okay. So welcome, everyone. I see lots of folks in the chat coming from all over. We've got lots of folks from California today, too, actually. California represent, woo. But also we've got Europe, Netherlands, it's late there, Bogota. We've got South America. That's Central. That's awesome. All right, welcome, everybody. It's great to see people interested from all over the world. So let's dig into day 1, how we can host Microsoft Agent Frameworks on Microsoft Foundry. So if you want to follow along with the slides or use the slides for your own teaching or learning, they are available at this URL, and we will put this URL in the chat as well so that you can grab them. So we're going to cover quite a lot today, showing how we can use Foundry for many components of agents, not just the hosting, but also the models, the knowledge retrieval, and the tools, and also with workflows. So lots to cover today. That means that I won't have much time to actually answer questions in the chat, but I've got my colleague Gwen in the chat. She's the one who does our Spanish series, and she knows all this stuff as well. And we're doing an office hours after every live stream. So if you do have questions that don't get covered in the chat, please come over to Discord afterwards for office hours, and that will give us questions to talk about during office hours. So all of the code is available that I am showing today. It is in this repo. So we'll put this URL in the chat as well. And you can, clone this repo locally, fork it to your account, whatever you want to do. You can also open it in GitHub code spaces. So, here it is. It's all in this repo. Now, normally we try to make it so that you can follow along with our code without having to do anything. But since we're talking all about hosting on Foundry, you do need to deploy onto Azure. So if you want to, afterwards, if you want to actually get this working on your account, then follow the instructions in the README in order to deploy all this. But all the code is available. It's got all the infrastructure, all the scripts, everything you need in order to run it locally and on Foundry with all the Foundry resources. So hopefully that's helpful for you. And if you have any issues afterwards with running it, please just file an issue in the issue tracker and I will reply. So let's start off briefly talking about agents. We have to always clarify what is an agent. I think we've all basically agreed at this point that an agent uses an LLM to run tools in a loop in order to achieve a goal. And it's really the loop and the tools that makes agents so powerful. Now, we often will add additional things to agents. So we might add memory, like short-term or long-term memory. We might add an explicit planning step, or maybe we just use a reasoning model that's kind of got it built in. And we'll often have human in the loop. So at certain points, maybe the agent will pause and ask a human for input. So that's how we can make our agents more sophisticated. But the general idea of agent is that we've got a goal, we've got tools. The user, sends something to agent and the agent says, okay, well, based on these possible tools, which ones I'm going to call in what order in order to answer this question, right? Sometimes it might need only one tool call and sometimes it could need 20 tool calls. And once it, realizes, oh, this is actually a hard problem. And that's why it's important that an agent is actually a loop, because it gives the agent that ability to keep searching for a solution using all the possible tools at its disposal. If you do want to learn more, dive deeper into agents, we did a whole 6-part series about Python and building agents with Agent Framework. So you can rewatch that series at this URL here if you want to dig really deep into agents. So this is just an example of the agentic loop, right? So if we say, we tell the agent, hey, you're a weather assistant, and we give it some weather tools, right? And then the user says, oh, well, what's the weather in Tokyo? And then the agent will use the LLM to say, oh, okay, I think we should call that get weather tool and pass in Tokyo. And so we call that tool and get back a response. And then the LLM says, oh, okay, well, according to that tool response, it's sunny in Tokyo and 25 degrees Celsius, right? And then the user says, oh, how about London? Like, okay, well, now we're going to call the weather tool for London. And we get back a response for that. And the LLM says, okay, well, based on that response, London is rainy. So that's the general idea of a agentic loop with tools. Now, you can write your own agent just using access to an LLM and some, local tools, but we generally recommend using agent frameworks. They will make it much easier to handle that tool calling and have a more sophisticated agentic harness that can, deal with things like memory and context window, limits and all of that stuff. So, that's why people tend to use agent frameworks. So from Microsoft, we have a framework that is called Agent Framework. It's a great name. Great name for an agent framework. I like it. It's very descriptive. It, it does what it says. And that's what we're going to be using today. There's also the very popular LangChain, and they have this new version, LangChain V1, and we'll be using that for the next stream. And then I also use Pydantic AI quite a bit, and that's from the creators of Pydantic. So these are the top 3 that I tend to use. You might have your own favorite agent framework. You can mention that in the chat if there's one you really like that you're not seeing here. But generally it is good to use an established agent framework because it will do some of the hard parts of the agentic loop for you. So today we are focusing on a Microsoft Agent Framework, which is currently available in Python and C#. We'll be focusing on Python today because I like Python. And so Agent Framework, it is, open source packages, multi-language packages that contain all these useful primitives and classes and functionality in order to build agents and workflows. Now, Agent Framework is actually a combination of 2 frameworks. So before we had Semantic Kernel and Autogen. So, they were both quite popular with different crowds. Semantic Kernel was more folks writing these enterprise systems, and Autogen was kind of more research focused and had interesting agent orchestration patterns. So, and people were always like, oh, which framework should I use for Microsoft? So now you don't have to pick. Now you just use Agent Framework. And, if there was something you liked from Semantic Kernel or something you liked from Autogen, you can generally find an Agent Framework. And also Agent Framework now has way more that you couldn't find in either of those, right? So definitely if you're using any of those two frameworks, you do want to move over to Agent Framework now. Agent Framework is, at least the core is now considered generally available. So how do we install Agent Framework for Python? You actually have a few options. So the first is that there is this all-in-one package, Agent-Framework, and that brings in a ton of basically like sub packages that have lots of functionality. So you can do that when you're playing around with it and you just want to have access to everything. However, what I would actually recommend for your more production scenarios is to be more selective because Agent Framework gives you that option. So you're going to start off with Agent-Framework-Core. That's the core. So you always want that. And then you just would install the packages that you need, right? So maybe you need maybe you need Foundry, right? We'll be using Foundry today. Maybe you want Foundry local, maybe you want OpenAI, maybe you want Ollama, right? So you can see there's all these sub packages that have specific functionality. So that way you can only bring in what you actually need for your project. And that's helpful because a lot of these also have their own transitive dependencies that they bring in. And so you don't want to have to bring in dependencies that you're not using, right? So I like this is what I'm going to recommend, and this is what we tend to do. Now, it's also important that you pin your versions. This is so important, especially in this day of age with AI, causing all these vulnerabilities. You want to pin your versions, meaning that your code is always using a particular version, and you only upgrade it to a new version when you've explicitly tested it locally and verified that you like that new version, and the new version has no actual vulnerability issues, right? So there's many ways you could do that, depending on whether you're using pip or UV. We are using UV today, so I'll show you what we do. So I have this pyproject.toml, and so in this pyproject.toml, you can see that I've included I've got the core, and I said, okay, it has to be at least 1.0.1 because that's what has the Foundry stuff that we need. And then I've got OpenAI, I've got Foundry, I've got Foundry hosting. Now you see some of these are only alpha right now. So these are in public preview right now. And that's, you can tell because of the alpha signifier in the version number. So this is what I have in my pyproject.toml, but I'm using UV. So UV makes a lock file. So if you look at the lock file, it says, hey, we're bringing in this exact version, and here's actually the exact place that it's getting it from. So this is what I mean by, pin your version. So here I'm saying, hey, I need these packages, and here's the minimum version that works, but then I'm using this UV lock file so that I have to explicitly upgrade the versions and change this lock file if I want to change to a new version. So that's the best practice. That's what I would recommend. So let's start off making the simplest agent we can make that has a tool. And this one, I'm actually going to use a local small language model that's on my machine. So this is with Ollama. There's a few ways you can run models locally. So there's Ollama, which works well on the Mac. There's also Foundry Local, which works on Mac and Windows. I think both Ollama and Foundry Local work on both of them. So let me just load this up. Okay, so if we say Ollama list, there we go. So you can see I've got various models locally. The one that I like the best right now is Qwen 3.54b. So this is a 4 GB small language model that I can use when testing locally when I don't have a nice deployed frontier model. So that's just what we're starting here, just to demonstrate the basics of an agent, right? So here we're using the OpenAI client. So this means we're using an endpoint that looks like an OpenAI endpoint from Ollama. And then we have this Python function here, and we decorate it using the tool decorator from Agent Framework. So this is how Agent Framework knows, oh, okay, this is a tool we're going to pass to an agent. So that agent is going to see the name and the return value and the doc string. And then we create the agent and say, okay, here's our agent. This is going to be the client. So it's going to use that Ollama client. Here's the instructions. This is our system prompt. I gave it today's date. And then here's our tools. And our tools here is only a local Python function, okay? So we're going to see a mix of local tools and remote tools here, but in this case, it is just a local Python function. And then I can run the agent and pass in a query, right? So say, okay, well, when does benefit enrollments open? That's a query that it should want to call this tool to answer. So now let's check it out. Here I ran it earlier. So here we go, UV run on this file. And I'm also logging just so we can see what it does. So we can see it made a request to my local Ollama OpenAI endpoint, and then it decided to call the function. And it called the function, it got back a response, and then it sent that to the LLM in order to respond based off of the tool call response. So that is our most basic function here. All right. So here we go. That was our very basic agent with tools. So now we are going to move to Foundry, right? So we've seen that we can run an agent entirely locally using an SLM. How can we build more powerful agents using everything that's available in Foundry? And that's what you're going to want to do for production, right? That SLM worked fairly well for that local query. But it's going to have a harder time as you throw more information at it and give it more powerful tools. So Microsoft Foundry has a lot of features that we can use when we're developing these AI applications. And we're going to use almost all of them today. So we've got Foundry models, so we can get access to frontier models. We've got Foundry IQ for knowledge retrieval, for RAG, as you might also know it as. We have agent servers, and that's how we're going to host it. And then we've got tons of tools and also the Foundry Toolbox where we can collect all those tools together. And then we've got, everything we normally expect from Microsoft is the ability to, have security and authentication and governance and all of that. Let's start off with Foundry models. So that is the first thing we're going to do, is go from our small local model to a Foundry model. So Foundry has technically access to more than 11,000 models. Most of these are because they're from Hugging Face, right? So there's just an incredible number of models on open source, on Hugging Face. Now, the models that matter to me tend to be the ones that are like really, really the frontier models from the frontier labs. So I'm usually using either the OpenAI models or now the Anthropic models, which are on Foundry as well. Or we've also got Mistral, Kimi, so there's a lot of options. And what's nice is that in Foundry, you can actually search at models and then you can look at their leaderboards. So there's leaderboards, so you can see, oh, okay, which models are the best in quality, safety, right? Especially like when a new model like GPT 5.5 just came out, so we could, go and check its leaderboards. And then you can select two models and say, hey, I'm deciding between, Opus 4.6 and GPT 5.4, compare these and tell me how they compare. So all of that is available on Foundry models. Let me open that up just to show you where we get to it. Let's see. We can navigate to it and this is all in the new Foundry experience. Let me sign in again. Okay. And it's good. Everything is very protected on Microsoft. So we've got our two-factor authentication before I can sign in. And now we're getting redirected back to Foundry. And I saw there was a question about C#. Yeah, so we're doing everything in Python for this series, but everything that you can do in Python, you should be able to do in C# as well. So if you go to Discover, then you'll see the Models tab. And in the Models tab, that's where you can search and also where you can compare and where you can view the leaderboard. Let's see, why am I getting 0? Oh, I must be in a funny. All right, let me change my projects. Okay. All right. Let's move on. There's something funny with my Azure account today. So I do also have everything preloaded because my Azure account's being funny today. So in order to make an agent that uses Foundry models, the only thing we have to change is that OpenAI chat client. So what we do is change the base URL to point at our Foundry OpenAI endpoint. In this case, we're using the OpenAI models. If you're using Anthropic, it'd be slightly different. But for using the OpenAI models, we'll just change the base URL to point at our Azure OpenAI endpoint. And then we'll pass in our Entra credentials as the token providers for keyless auth, and then we'll pass in the model that we've deployed, right? So in this case, I think I'm using GPT 5.4 for all of these ones. So that's the only thing we need to change. Everything else remains the same, right? All the rest of the code is the same. We just changed that OpenAI chat client. So here you can see that's running. So I ran that earlier. And so really the only difference is that now when we're making the request, that request is going to my Foundry account instead, right? So it's saying, hey, LLM, this is what the user wants to do. The LLM says, okay, let's call this tool. It sends back the tool response to the LLM, and then we get back the answer from the LLM. So very similar to using Ollama. It's just that now our model is deployed onto Foundry, and we generally will get better responses when we're using the more powerful models. So I just saw a question about RAG, and that leads as well into Foundry IQ. So if you want your answers, if your agent's answers to be grounded in knowledge from your internal knowledge, then we recommend using Foundry IQ. Foundry IQ is basically Azure AI search. It's the way we refer to it when it's inside Foundry. So it is using the Azure AI search agentic knowledge base in order to do agentic retrieval, and you can do it across multiple knowledge sources, which is what's really nice. So basically you want to get your data and have it available in one of these possible knowledge sources, right? So you might put in a search index if it's something like you're just indexing, you've got like folders and folders full of PDFs. Okay, you go and index them, you put in the search index. But you can also point AI search at OneLake, at SharePoint, at just an arbitrary MCP that's in private preview right now, but it can support a wide range of knowledge sources. And then when the agent, sees that so what we're going to do is say, hey, agent, you have the ability to use this knowledge-based retrieval tool, and this gets exposed over MCP. So MCP is a way of exposing functionality so that agents can use tools from servers in a standard way. So there is an MCP endpoint for this AI search knowledge base, and the agent can then say, okay, I'm going to call the tool knowledge-based retrieve, and it decides what queries it's going to send, and then AI search will send all those queries across to all the possible knowledge sources, get back the results, merge those results using a semantic re-ranker step, and then get the results back to the agent. And so then the agents will see all those merge results and decide what to do with them. So that is what we're going to use. And so we are using it as an MCP tool. So what we do is we set up our knowledge base in AI search. And so that knowledge base, has however many knowledge sources in it. And then we say, okay, this is our AI search endpoint. This is the knowledge base name we're using. We're using the /MCP URL here. And then in order to point the agent at that tool, we use this class from Agent Framework called MCP Streamable HCP tool. So this comes from Agent Framework, and we say, hey, here is a MCP server, and these are the tools that we want to use from it. There's just one tool. And here's the URL. We give it a client that has the authentication information, because of course we're authenticating securely with our credential. And now the agent, inside the agent, you see here, we say, hey, you're going to use this MCP tool. So this agent now has two tools. It has the local tool, which is a Python function, and it has this MCP tool, which is basically a remote tool, right? And so at any point, the agent can decide, all right, I've got these two tools. I can either retrieve from a knowledge base, or I can get enrollment info. Which tool do I want to use in order to answer the question? So looking at that example here. So here, when I run it, so here I'm saying, okay, we're going to run this code. And it actually starts off with a lot more requests than before, because now it has to do a little handshake with the MCP server, right? So it's saying like, okay, hi MCP server, what tools do you have? You know, which of those could I use? So all of this is required. That's the overhead of using MCP, is that the agent needs to do a handshake with the MCP server and say, hey, MCP server, what tools do you have? You know, what do they look like? What are their names? What are their arguments? You know, how can I use them? So all of these calls here are just basically the, you know, finding out from the MCP server what tools are available. So then it's all set up and it says, oh, okay. It actually suggests we, you know, for this particular question, it's going to call both that MCP tool and the local tool. And then we get back the results, right? So this is an example where, let me show the question that I sent to it. I said, what perks plus benefits are there and when do I need to enroll by? So this was a question where it actually had to query both those tools in order to answer them. So it had to both use the local Python tool and the Foundry IQ MCP tool. So then we get back this answer. Here's the benefits. Here's the source. It's from this PDF that was indexed in the search index. And then this is when you need to enroll by, and that came from the local tool up here, right? So now we're starting to build a more powerful agent that's able to, you know, actually pull in our domain information and use that in order to answer questions, right? And so when we're writing our system prompt, we also want to make sure in our system prompt that we make it clear, like when it should be using, you know, different tools available. That'll just help it with its decision process. Okay. Now, you might want other tools as well besides just the knowledge retrieval tool. And in fact, Foundry has access to lots and lots of built-in tools and is trying to make it easier for you to bring in those tools for use by any agent. So Foundry now has this thing called the Foundry Toolbox, and this was just released very recently. And the Foundry Toolbox can collect tools from the Foundry tool catalog so that you can just make a toolbox and say, hey, I've got this toolbox of common tools I like to use. And any agent you have can just point at that toolbox. And that toolbox will basically be like an MCP server as well that exposes each of the tools that are in the toolbox. So what we can do is build a toolbox that includes that Foundry IQ MCP server, but also includes the web search tool, which is a really cool tool because it's powered by Bing. So you can actually search the web, and, you know, that can make your agents have much better answers if anybody's asking about anything that's, you know, current today that requires more grounding in web results. It can also include Code Interpreter, which is another built-in tool which does sandbox Python execution. And that is so helpful as well, because then your agents can answer questions that require more complex like math calculations, or that can do like image manipulation, you know, using like Panda, Pillow and stuff like that. So I really like to have both web search and Code Interpreter enabled for all of my agents to make them more powerful. But it depends on what you're building, right? So, you know, for today, we're going to use web search, Code Interpreter, and Foundry IQ as our 3 tools for our agent. So the first thing we have to do, since we're using Foundry Toolbox, is create a toolbox from here. I'm making it from code, just using the Toolbox REST API. I'm saying the toolbox is a very, very new concept. So right now, the only way to make a toolbox is programmatically is via the REST API. So that's what we do here. We say, hey, we're making this toolbox. It has these 2 built-in tools. It also has this MCP endpoint here, which is the knowledge base. And here's the information. And it's going to use a project connection in order to connect to that securely. So we make the toolbox. And then once we have the toolbox, we can point any agent at that toolbox. So in order to do that, this looks really similar to Foundry IQ, because the toolbox is itself just an MCP server. So we're going to make it, you know, an MCP tool again and say, hey, this is our toolbox. this is the Foundry project endpoint. You're going to use this toolbox and use its MCP endpoint. And then this time when we do tools, we're going to point it at our local function and that toolbox tool. And that way we have everything together. So then when we run that, or actually I already ran it so I can show you. So we can see that this time it's actually going to, let's see, for this question, I had it search the web as well as searching from a knowledge base. Yeah, I have to relog in. So let me just show you the actual code. All right, so let's go and look at the code for this one. Stage 3, Foundry Toolbox. Okay. All right. So here we have our Foundry Toolbox set up here. And yeah, and so it's got access to those tools. And so it decided to do both the knowledge base retrieve and web search and got them both from the toolbox. And the question I asked for this one was, does Perks Plus cover scuba diving, and how does that compare to Perks Plus at other companies? So it had to use the knowledge base retrieve tool to answer this part of the question because this was an internal question. And then it had to use the web search tool to answer this part of the question, right? So now we can see how we can ground answers in both our own internal information and combine that with information from the web in order to be able to answer a wider range of questions, right? And this is the kind of question that people might reasonably have, right? So we get back the answer. It says, okay, so for Zava Perks Plus, yes, it's covered. Compared to other Perks Plus, okay, well, Microsoft, it doesn't say United Perks Plus, right? So it tried to go and find information from the web in order to answer that question. And, it actually did a pretty decent job. So here we have, so that's our toolbox, right? And there's many other tools that you could add to that, and you can, add any arbitrary MCP tool as well. So finally, let's talk about Foundry Agent Service. So we've got, now we've got those agents. I was all running those locally, right? But once we're happy with our agent, we're probably going to want to actually run that on a server in production. So Foundry Agent Service is a way of doing that. It's a platform for running your agents, and it supports two kinds of agents. The one it's supported for a while, and originally it's called a prompt agent, and that's where you're just telling Foundry Agent Service like, oh, here's my instructions, here's my tools, and just using its way of its own agentic loop that's built in. But what we're doing today is hosted agents, and that I like better because there we can bring our own agent framework and use the agentic loop and all the functionality from the agent framework. So hosted agents is a more generic platform that can potentially host any sort of agent framework. So today we're doing agent framework. We're going to do LangChain next. But in theory, if you had another agent framework, you could bring it as well. And both of these can use, all of this Foundry functionality as we've been seeing, as we've been building up our agent to be more functional. So how does it actually work when we want to host a Microsoft Agent Framework agent? So there's actually two ways of hosting the agent, basically because we want to have a common way of interacting with the agent. And so there's two options. One is that you put a responses API in front of that agent, and that becomes the way you interact with the agent. The responses API is based off the OpenAI responses API, and now there's the open responses spec. So it is like a fairly well supported way of interacting with, models and now agents. So that's one option. And that's what we're going to be doing today for this series, is using the responses API in front, because it gives you more functionality when your agent is supporting the responses API. But that in order to do that, that does mean on top of our code, right? So we have our code, we need code that then adapts our code to receive input in the form of the responses API messages and send output in the form of responses API as well. So we basically need some sort of adapter between, that's going to make our code conform to that shape. Now, if you don't want to write that adapter, then you could use that more generic invocations API, which is basically just, you get an HTTP endpoint, you send whatever you want to it, right? But I like doing the responses API route because it unlocks more Foundry functionality. So basically, we have our code, we put an adapter on top of it. Then that gets packaged up using a Docker file as a container, and that gets stored in Azure Container Registry. And then finally, that we set that all up on Foundry Agent Service so that it can pull the container from the container registry and serve it using this new micro VM platform, so it can serve it very quickly and with great isolation as well. So how this actually looks like with agent service in Python is that we have our code, right? So remember our agent code. So we have, agent, and this time our client is going to be the Foundry chat client. And then our adapter is from the Foundry hosting agent framework package. So we actually import it from agent framework. So in this case, agent framework itself has decided to add formal support for Foundry hosted agents to make it super easy to bring your agent framework agents to Foundry hosted. So you're going to bring in that special package and that server and then wrap your agent in it. So you're going to say, okay, I'm making a new responses server that's wrapping this agent, and then I'm running that server. And so that'll literally run a server that has endpoints that look like responses API endpoints. And then we use a Docker file and an agent.yaml in order to describe our, how we're going to build that container and how our agent works, and then run it in agent service. So then if we look at the full Python code here, right, we're bringing in everything from agent framework, including that new responses host server, and creating this Foundry chat client, using that as the client, running the server, and then boom. Then we need to deploy it, right? Because now we need to actually get that container built and up onto Azure. So we are using the Azure Developer CLI. So first we log into the CLI, and then we run AZ up. So what that does, it makes all the infrastructure based off of bicep files. It builds the image using the Docker file. It pushes that image to the Azure Container Registry and deploys that new agent to Foundry and auto increments the version of the agent in Foundry. So just looking at how that works. All right, so we've got a few components here. So we've got the agent.yaml, right? So here's the agent.yaml. So it names the agent and it says it's using the responses protocol. And we also say, the CPU and memory resources necessary for the micro VM that is going to launch. We can also inject some environment variables into the container if needed. Then we have the Docker file, and the Docker file, installs sets up a Python container, installs all the requirements, and then does a little health check, and then runs this code here. And then in that code, that's where we bring in the responses host server, and we just run that server when that code gets run. And then for AZD, here's what the AZD up looks like. It'll package things up. It'll provision anything. In this case, it didn't have to because it was already done. And then it'll deploy. And when it deploys, it actually, what's really nice is it gives you a link to try out the current version of the agent. You see this is version 29. That's the one I just did. So this is actually a link that opens up Foundry. So then let's go to Foundry. So here it is. I have it open. So I already asked that same question. What perks plus benefits are there, and how do they compare to other companies? So we get back this really nice answer, and then how it compares. And the cool thing is you can see the log stream here that's coming in from the container, from that micro VM. So it like from a development perspective, I really love having the log stream right here. Like I really, really like this. I always struggle with finding logs when I'm, deploying on Azure, but now we've got the log stream right here. So I think this is a really nice feature. And I use this all the time so I can see everything going on. And I have very verbose logging because I love my logs. So here we go. So it's, so here you can play around with it in the playground just to try it out. But you can also, using the responses API, you can interact with it anywhere else, right? So you could also interact with it from code, right? You just have to make a HTTP request using the responses API to that endpoint, with the right authorization, and then you can get back a response. So you could do that with HTTP. You could do that with the Azure AI Projects SDK. You could do it with the OpenAI SDK. As long as you have a way of, using responses API, then you can interact with your deployed agent. Yeah, I see a question about these micro VMs versus container apps. So the previous version did run on container apps. The change that was made last week was this new platform. And I don't even think there's like an official name for the platform yet. I think if you come to build in June, you might hear an official name. So right now I've just been calling it like the fast micro VM platform. Yeah, so they're running on some great technology that has very fast startup time and is better for doing session isolation for each of the agent runs. And we'll have more to talk about for it at build. Let's see. The other thing that's nice is that we can also run the hosted agent locally if you want to test out to see what it's like. So you can see, you just use AZ AI agent run. Let's see, where did I start off you can see all my logs. Okay. So when you do AZ AI agent run, then it'll start off a local version of the responses server. So you can simulate what's going to happen in deployment, right? Because, you always want to be able to simulate as much locally as possible. So this is, running that server, and then we can do, we can invoke that server. So we say, okay, AZ AI agent invoke local, and that's going to hit up that local server, localhost URL, and get an answer to it, right? So you have this same experience locally as well. So I think that's really nice having that local development experience in addition to the deployed experience, because you want to always test as much as you can locally before you actually have to do deploy. Even though the deploys now are really, really fast, because that's another thing about this new platform is that the deploys are very fast. Okay, now let's talk about observability, because that is a big feature of this as well. So we're going to be doing observability using OpenTelemetry. OpenTelemetry is an open standard for how applications can emit traces, metrics, and logs. And we generally are big users of OpenTelemetry at Microsoft and like to have support for it in all of our products, both in terms of emitting and also, visualizing anything from OpenTelemetry. So that's what we're going to be using for our for all of our traces. So how do we use that with Agent Framework? So Agent Framework actually has several functions that make it easy to use OpenTelemetry. The one we're using today is called Enable Instrumentation. So we import that from the Agent Framework Observability package. And then we call it before any of our important code runs. So we want to call it really, really early, like at the very top before anything runs. So we enable instrumentation. And in this case, I'd said enable sensitive data true. So I could get my tool call results in there. You'll have to decide whether you want to do that for your production deployment. But when we call that, then it's going to instrument all of the agent calls and tool calls so that they emit OpenTelemetry traces using this generative AI semantic conventions that is used across the industry. So we're not the only ones using this. So that means like there's actually standardization across multiple vendors and agent frameworks for how these traces are being exported, which is nice. I always like when we have standards. So you'll see that like when a tool gets executed, you'll see all these like, genai.tool.name, genai.tool.call.arguments, right? So Agent Framework will make sure that, those spans get exported. Now we still need to bring those spans into our, into a platform for viewing them, right? So that's called exporting. So we still need to export those spans to somewhere. So in this case, we're going to export to Azure Application Insights because that is an OTel compatible platform. And that's what Foundry integrates with directly. So what we can do here is when we already did it. So when we set up responses host server, that has code that will look for the application insights connection stream, and it'll automatically set up the exporter to that app insight. So as long as you've, basically all you just have to be using this, this code here, and it'll export to app insights for you. So then once we've done that, then we have access to traces in Foundry. So my favorite way to view them is to go to the traces tab, and that'll load up. Okay, I see Foundry. Someone was saying Azure was having issues. So good thing I took screenshots of everything. So you go to your traces tab, you click conversations, and you will see all these traces from the conversations. And when you click on one of those, then you'll see this really nice sequence of calls that happen, right? So we can see like, okay, we invoked the agent, then we called GPT 5.2, then we called the web search tool, then we called the knowledge base retrieve tool, then we called the LLM again, then web search, right? So you can see the whole sequence of steps that happened. And when you click on each of those, you can see all the attributes, that describe everything that happened at each point. The other thing that's nice is that Azure App Insights also now has this new agents tab that is, similar, but shows more like overall stuff. So this will show agent runs, errors, like which tool calls are happening the most often, which ones have the most errors, the average duration. So you get really, really cool charts from App Insights now as well. And that's really easy to get to from Foundry. You just select the Monitor tab, and there's a button that'll open Azure Monitor. So you've got multiple ways of, browsing, going through all these traces, and trying to understand how your agent is working, and you can just use App Insights as just the regular way too, because this is all just using open telemetry. All right, so now finally, let's talk about workflows. So you may want to go beyond a single agent and actually be putting together multi-agent workflows. It's very common when you're starting to actually do some real processing with agents. So a workflow is any flow you make that involves an agent at some point, and usually that agent is either deciding like kind of what branch where to go next in the workflow, or it's maybe synthesizing an answer, or maybe it's doing some entity extraction. There's lots of ways you might use that agent in a workflow. But there's many workflows that you can start to add agents to in order to make them more powerful. So in Agent Framework, there is built-in support for workflows, and the way that they describe workflows and the way they make them is that a workflow is a graph, and the nodes in the graphs are called executors. So each node is an executor, and there are edges between the nodes, and there's a start edge and an end edge as well. So each of those executors has to define methods that can receive messages from the previous executor, and that will then send messages to the next executor, or they'll just yield an output. So they either need to send messages along or output something. We had a whole 3 days talking about workflows in our last series. So if you do want to learn more about workflows and agent frameworks, do watch those videos. Here is a really simple workflow that doesn't use any agents at all, just to show you what workflows look like in Agent Framework. So we have 2 executors. One of them turns text into uppercase. I know this is very exciting. And the other one reverses the text and outputs it, right? So this is to show that the first one uses send message in order to send the message to the next executor. And the second executor just does yield output in order to yield that as an output that can be queried as an output from the workflow. So we use workflow builder class and say, hey, this is our start executor, it's upper. We're going to add an edge from upper to reverse, and then we're going to build, and then we run the workflow and we get the outputs from it, and we'll get back the very exciting reversed uppercase text. So that's a really, really simple workflow, just so you see the idea of how workflows work in Agent Framework. Now, a lot of times it's more exciting if some of your executors or all of them are agents. So in this case, we have these agent executor nodes, and these basically are just taking an agent and then wrapping them to turn them into an executor. So our agent, we've got a writer and we've got a formatter, right? So we say, okay, we've got our two agent executor nodes. This is the start executor is the writer, the output executor is the formatter, and then we're going to add an edge between the writer and the formatter, and then we have that workflow. So here, this is where I ran it. So I told it to write a 2-sentence LinkedIn post, why your AI pilot looks good but fails in production. And so that went through the writer, and then it definitely went through the formatter because I told the formatter to add lots of emojis. And I see a lot of emojis. So I can definitely see that it went through both steps here. Now, the next thing we need to do is turn the workflow into an agent so that we can make it compatible with Foundry hosted agents. So all we have to do there is after we build the workflow, we just call .asAgent and we give it a name. And now we have an agent wrapping that workflow. And it's going to, I mean, the thing is, it's basically, it's going to work the same as the other one. It's just slightly different code, right? That leads us into the ability to host our agents on Foundry. Because now, well, we've got an agent class again. We can just do exactly what we did before, right? We're going to take our workflow and say, okay, as agent, and then pass that workflow as agent to the, to that responses host server, and then run the server, and then boom, we have a workflow as an agent. So I've got that. And then we're do AZ up as well. So in this repo, you actually see this is basically a mono repo that has both an agent and a workflow, and each of them has their own setup. So if you look in the workflows folder, you'll also find a Docker file there. So that's running the workflow file instead. You'll find it's got a PyProject.toml as well. It's got an agent.yaml, and this one has a different name. So this one's called -workflow, and it has some different environment variables. So you can actually have multiple agents and workflows inside a repo, as long as each of them has their own folder that has a Docker file, agent.yaml, and all its requirements in there, right? And then, I've never showed our Azure.yaml. So our Azure.yaml, this is used by AZD. You can see in the Azure.yaml, we have multiple services listed. So one of them is the agent service, and that's referencing the agents folder. And the other one is the workflows one. So as you add more agents and workflows that you're hosting in Foundry to a repo, you would add more to your Azure.yaml as well, so that it could deploy all of those at once. Because then if you look at my AZ up, you actually see that indeed it deployed both the agent and the workflow to Foundry, and gave us the links for both of them, right? So we've got our playground link, our endpoint, and got them all deployed. So that's really nice as well. The ability, the having support for being able to deploy multiple things from one repo. All right, so let's see. So here we go. This is the workflow, and you can see it looks the same, right? Because to Foundry, this is just an agent that is being exposed as responses. The difference is that now, it's running different flows. As you can see, this has lots of emojis because it went through both my writer and my formatter that likes to add emojis. So the workflow, worked. And once again, we've got all the logs, and we can actually see as it went through the logs, we can actually see here, you can see it says, okay, starting steps of the workflow, right? Starting super step 1, and it's going through the various stages here, and goes through the next agent. It saves a checkpoint. So everything we expect out of workflows is working inside of Foundry. Okay. And what did I have open over there? No, that's the thing loading. Okay, great. All right, so now we've seen workflows. Okay, it looks like I actually zoomed through those, and I know that I didn't answer any of the questions at all. We do have the office hours after. I do have 5 minutes right now, so let me see if there's some good questions here. Oh, there is a good question. I just saw it. What about memory? That's a great question. So Foundry does have memory. I have not played with it yet. Let me see if there's a example for memory in We did talk about memory in our last series, right? And how to do memory with like mem0. We did it with Redis, etc. But there's also this Foundry memory service that I haven't tried yet. So let me just take a look. So I always recommend for Agent Framework for Python, check out the samples folder. That's where I often go to just to see, has something already been, done here? Okay, so we got basic workflows, blah, blah, blah. So that one doesn't have memory invocations. Ooh, what's this? Breaking glass. Fun. Okay. All right. So I don't see an example there of memory. Yeah, it's a good question. Okay. What about our Foundry toolbox? Create toolbox. Which tools can we add? Yeah, we should figure out, okay, introducing toolboxes in Foundry. Would tools have? This is a great question. I should definitely figure this out. So we did talk about memory. Like if you go to our previous series, we talked about memory there. So Python agents, and there when we did memory, we did we did mem0, right? So you could certainly do that. And that's nice. But with Foundry, we should also be able to do Foundry memory, because that's a a hosted memory service, and I just have not done that yet. So here we go. Oh, Foundry memory. Okay, great. So create a memory store. Okay. All right. So I think that this is definitely something we should add to the sample, so that we have a good story for about how to use Foundry memory with hosted agents, because we've pretty much done a lot of the other stuff here. So yeah, that is a great question. So I'll look into Foundry memory and see if there's like a even tighter integration. You can reference that article. You can also, of course, set up memory with mem0. There's also, we looked at Redis. The built-in memory option for Redis isn't that great. It's a bit naive. I think the mem0 approach is much nicer. I believe Foundry memory is basically using a similar approach to mem0, where it's a little more curating of the memories. So when you're storing memories, you have this question of what memories are in your store. What are they going to look like? Are you going to use an LM to extract the memories? How are you going to update old memories? How are you going to delete memories, right? So mem0 does take care of all of that. And I believe Foundry memory has a similar approach to mem0. All right. So we'll dig more into that. Pablo asks, can hosted agents be deployed to specific regions? All right. So let's get the docs for hosted agents up. So right now, it is only specific regions. Deploy a hosted agent. Let's see if we get the region support here. Nope. Let's check here. Region availability. There we go. All right. So it is a limited number of regions right now. Australia East, Canada Central, North Central US, and Sweden Central. So hopefully you're near one of those. And if not, they're obviously going to add more regions. And we also, in our bicep, when I set up the bicep, I have the same, I think I have mostly the same ones here. Maybe I don't have exact. So North Central, Sweden. Okay, it looks like I have some disagreement there. So I should actually update this. Foundry hosted. So it looks like actually I need to update this. So I am currently using North Central US. That is what, if you were doing it today, that's what I'd recommend. It's working. It's working pretty well. I was saying Foundry hosted agents, like the new version just came out last week. So there are some rough edges at like currently, and you'll see when you look at my actual code, you will see some notes about current bugs and workarounds and whatnot. So we are learning it like while it's in public preview when it just came out. So definitely try it out. But also when you have issues, do let us know and report them so that we can make the product better, so that when it gets to be generally available, then it'll be all shiny and all the bugs worked out. All right. Great. Okay, so it is now at time. So for additional questions, I'm going to recommend we go to Discord for them. And here's a link. So remember, if you're not registered yet, do register. We will link to everything from this resources thread. So this resources thread will have the slides. I will do a write-up for each of them as well. So you get like slides and text underneath the slides, and just another way of consuming it. I'll also probably upload office hours to this thread too. So yeah, definitely, bookmark this as well, so you get all the resources. And now it is time for office hours. So I hope to see you in office hours or on Wednesday. So we do not have a live stream tomorrow. And the reason we don't have a live stream is because Azure Cosmos DB conference is happening tomorrow all day on the Reactor channel. I do have a talk in that one as well. So if you want to see that, that'll be on the channel. It'll be released, I think, in the morning. But yeah, Azure Cosmos DB conference is happening all tomorrow. So that we will be waiting a day in order to do our LangChain talk on Wednesday. Okay, so hope to see you in the Discord. I will end the stream now and head over to Discord. Thank you, everyone. Bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.